Okay, so now we're going to talk about horizontal shifts. So maybe it'll be helpful if I show a little example here. So let's say you have the quadratic function. We know that the quadratic function goes through the point 1, 1 and 2, 4. And then also on the other side. Okay, so it looks something like that. Okay, the quadratic function. Now, what's going to happen is we're going to have, okay, here's the regular one, f of x equals x squared. But now what we're going to do, we're going to have a new function, g of x, say, and let's have it be x minus 1 squared. So what happens when I put in a value for x? Let's say I put in 0 for x, okay? Then what do I get out? Well, 0 minus 1 is negative 1, and I square it, I get a 1 out, right? So now when I'm putting in, this is like a table of values here, x and g of x. When I'm putting in 0, I'm getting 1 out. So 0, 1 is right there. What happens if I put in 1 for x? Well, when I put in 1, 1 minus 1 is 0, 0 squared is 0. I get the point 1, 0. What do you think is going to happen if you put in negative 1? Or I'm sorry, 2. I meant 2. Well, then you'd have 2 minus 1, which is 1, and you square it, you get 1. So you're going to have the point right here at 2, 1. And you can see the graph is looking the same, but it's done a horizontal shift, and it shifted to the right. Okay? So that's what we have to point out on this, is that it's shifting maybe the opposite of what you're thinking, because it's minus 1, but that's making it shift to the right. Okay, so you may have seen that working with quadratics before. So here comes the function notation. You take g of x for a horizontal shift, it's going to be f of, and then you're doing a subtraction before you apply the function. Now, in the vertical shifts, you applied the function, and then you added or subtracted something. Now we're going to have the input, we're going to add or subtract something to it, and then apply the function. Okay. If c is greater than 0, so like in this case, c is 1. In this case, c is 1. Not negative 1, it's 1, because it's written x minus c. Okay? So if it's greater than 0, it's going to shift to the right. If c is less than 0, it's going to shift to the left. Now that's often confusing to students. So if you have something like, let's see, a new function here. Let's say I have h of x is x plus 7 squared. That is going to shift, it'll be the quadratic function, but it's going to shift 7 units to the left, okay? Because you have to think of it as x minus a negative 7, okay? And so c in this case, c is negative 7. And that's why it's shifting to the left. Okay, sometimes that's confusing for people, so you can rewind it, and there's examples in the book too. Okay, so now we're going to go back to our example that we had in example 1, the air vents, okay? Suppose that in autumn the facilities manager decides that the original venting plan starts too late and wants to begin the entire venting program 2 hours earlier. Sketch a graph of the new function. Okay, so think about it maybe this way. What used to happen, t, so say at midnight, now we want it to be 2 hours earlier. Whoops, whoops, not like that. Oh, man. We want to take t and we want it to shift back. So we want it to come over 2 hours over this way. We want it to go to the left. So that would be t plus 2. And then the v function of that. So whatever this is called, s of t. It would be the v function, but we're going to be taking the input and adding 2. So think about it this way, what happens at midnight is now happening at 2 a.m. Yeah. Okay. Well, it just asks us to sketch it. It doesn't ask us to write the equation, but I thought it'd be helpful for you to see that. Think of it as v t of t minus a negative 2, like that, okay? And that's going to shift it to the left 2 hours earlier. So that means our 8 has to happen at 6. I guess or 6 is happening at 8. That doesn't make sense. Okay, what used to happen at 10 is now happening at 8. What used to happen at, I don't know, it looks like maybe 17 is happening 2 hours sooner. That is going to drive me crazy when it does that. And then what happened at 19 hours after midnight is going to happen like at 17 hours after midnight. And then finally at 24 hours, that's going to be 2 hours sooner, like at 22. So remember, the shape is staying the same. But well, the shape's kind of the same. The shape's supposed to stay the same, and it's shifting 2 units earlier, 2 hours earlier. Okay? All right.